sort of two things in trig that we need to know. So one is trig values, and that is if you saw the table that I said to memorize. Let's just recreate that first, and then I'll show you what the Joe Louis are for. So you were supposed to have memorized this. 0, 3 pi over 2, 2 pi. What order did I put them on the sheet? Pi over 6, 6, 4, and 3. And then over here, sine, cos, and we can add tan in. All right, let's do it really fast. Ready? What does it start with? 0, 1, 0, 1, 0. Done. Next line. 1, 0, 1, 0, 1. Which one's negative? The second one in each row is negative. 1, 2. There we go. Good enough. Here. Do I have these in a different order? Maybe. So what if you didn't remember the order you put them in? You remember the pattern, right? Do you remember the pattern of the numbers in there? So I always have one memorized just in case. So my name starts with C. Caroline, cookies, Christmas, all my favorite things. Cadeau in French. All right, so this one right here is 1/2, right? So where do we go from there? So that's like a root 1 over 2. This would be a root 2 over 2 and root 3 over 2. And this one is the opposite. Root 2 over 2 and root 3 over 2. 1, 2, 3, all divided by 2. And this one is backwards. Okay. Tan, do we remember? Tan is sine over cos. So what I've done by setting up the table this way is put sine on top of cos. So it's already a fraction, sine over cos. 0 over 1, 0. 1 divided by 0, undefined. Just put a line, or you can write undefined, but a line is fine, it doesn't exist. 0 over 1, 1 over 0, 0 over 1. Now remember what I said last class, when there's the 2 is the same, on top and bottom they cancel, so we've got 1 over root 3 here. Root 2 over root 2, just 1. And root 3 over 1 is just root 3, or you can write root 3 over 1, but just root 3. Okay, now we've got those all memorized and we're all good. Let's draw a little x and y axis here. So this now is going to be 0, and we're thinking of this as a circle going around, okay? So when we come to this one, that's 90 degrees, right? Who likes degrees better than these radians? Yeah, you're not going to by the end of class. That's my goal. That's why the Joe Louis. They're a bribe to make you like radians. What do we get when here's our start, and the angle starts here and goes all the way around to this line, 180. And here, 270, and back to the start, 360. So that actually means the 0 and 360 are the same. Okay, so you know this, and the angles and the size. Now you have no calculator, so working with the number 270 is actually a bit tricky. Okay, so we're going to talk about how to convert from radians to degrees, but what we're going to concentrate on today is just radians. Okay, so when we go around this circle, this is pi over 2, 3 pi over 2, or sorry, pi, 3 pi over 2, and 2 pi, but let me show you. So, I'm going to open these, but I'm on a diet, so I'm not going to eat them. I'm really bad at diets, by the way. I'm always on a diet. I ate a bag of candy last night. All right. if I could get these open. Okay, so forget about your grandmother's pie. These are math pies. Each of these is one pie, okay? So each of them is one pie. So your grandmother's pie is circle. In math, pi is a semicircle, like this, okay? Do you get it? Now, so this is one pie, and this is two pies. Now, how does that relate? Well, when we have an x and y axis, if we put this pie up here, okay? If I say you get to start here and you eat around the pie, you have to start from this end. I know you already ate yours, so you're not going to do this. But hopefully you don't have a knife anyway to cut up. So 0. So if I said you have 0, you get 0. You don't get any pie. But you eat from in this direction, okay? So we're going to go around the circle. This is the positive direction you get to eat. And if we get all the way to this line, how much of the pie? Now, I'm not going to eat them because I am going to play with this pie. That line is where I would cut it. So how much of the pie do I get to eat? This is a whole pie. Go back to elementary school. Forget about the pizzas they taught you fractions with. We're talking about Joe Louis. So if we cut it right there, how much of a pie do we get? Half. This is pi divided by 2. A pie cut in half. Do you see it? So if we get all the way to this line, how much of the pie do we get to eat? The whole pie. Now add another pie to this. This is the start always. A whole pie plus another half a pie is 3 halves. Do you agree with that? That would be 3 halves if you got to eat to here. They are 1 half, 2 halves, 3 halves. And then back to the start is 4 halves, which is 2 pies. So back to the start is 2 pi. Okay? So picturing these as pies, and we're going to move them. All right, so here, this is pi over 2, and so on. Pi, 3 pi over 2, back to the start, 2 pi. Okay, so now, what about these pi over 6, pi over 3, those ones? So let's draw a little. So picture your Joe Louis right here. There it is. Here's 0, and that's always our start. If I wanted to look at pi over 3, how would I cut the Joe Louis? If I want to cut that into thirds. So I cut it here and here, so that we'd have 3 equal pieces. Does that make sense? So we would cut it like here. Let's use a different color. And here, and then we'd have 3 equal pieces. But it makes up the whole. This piece, if we get this far, is 1/3. If we get this far, is 2/3. And back to the end of the pie is 3/3. Well, 3/3 is 1 pi, right? The 3's cancel. We could keep going around and add our second pie, cut that into thirds, and what would this line be? How many thirds would we get to eat if we cut it here and started from this end? 1, 2, 3, 4. 4/3 would be here. You see it? And then if we ate this piece, 5. And back to the start is 6 pi over 3. Well, 6 over 3 is 2. 2 pies if we get back to the start. Okay, so what I want you to do is draw this same picture, but for quarters. So if we were to cut the pie into quarters. So you're going to draw your 2 pies. 1, 2, 0, and this is our start. So draw the lines that would cut them. The cut lines are called terminal arms. So when I say where's the terminal arm, that would be where you cut the Joe Louis when you want that many pieces. So I want you to cut this in quarters and label them all. So do that, and then we're going to do the same thing for 6. So you're going to label quarters on this one, and 6 on this one. Okay, you've got your quarters done. So quarters, we can actually use that line that's already there from the axis. 1, 2, 3, 4, and then keep going around 5, 6, 7, 8. So if we went around 2 pies, we'd get to eat 8 pieces if they were cut in quarters. This first terminal arm is the pi over 4. That's 1/4. Here, half. Pi over 2, or 2 pi over 4. That reduces. What about to here? 1, 2, 3 pieces if you cut. So 3/4, 3 over 4, 3/4 of a pie. And here, a whole pie. Just 4 over 4 if you want. Next, 5 pieces. 6, so let's write that down. 6 pi over 4. What cancels here? A 2? So you have 3 pi over 2, which is what that line would be anyway. And the next one, 1, 2, 3, 4, 5, 6, 7 pieces, 7 pi over 4. And back to the start is 8 pi over 4, or 2 pi. Now, could we keep going around, is the question. Yes. The answer is yes. I could keep stacking these on top of each other and keep going around, okay? Or, in the real trig way, you wouldn't actually have stacked it. You would just still cut it, because in trig, if we went one more piece, we could say there's 9 pieces. Do you agree with that? If we added one more. So if I go here and say this is 9 pi over 4, in trig, you actually only get 1 piece. They're the same number. So you kind of go back to the start. It's just like a clock. When you're counting on a clock and you get back to midnight, you're back at 1 o'clock. It is later, or it is 13 hours late, or ahead of 12 o'clock, or 12 hours past the last 1 o'clock. It is a different time. But in clock world, the clock doesn't care. They say it's 1 o'clock, doesn't matter AM or PM, it doesn't matter. It's back to the start. Okay, so with trig, it's the same thing. 9 pi over 4 is the same as only getting to eat 1 piece. So the most you can eat is 8 pi over 4, and then you sort of start all over again. Okay, but those are equivalent, so we can go around. What about 6? Can we use these lines again for 6? If we're cutting this pie into 6 pieces, cut it 1, 2, 3, 4, 5, 6, each half into 3. 7, 8, 9, 10, 11, 12, and you could label them. Pi over 6, 2 pi over 6. What's that the same as? Pi over 3. Pi over 3, pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6, pi. 7 pi over 6. 8 pi over 6. 4 pi over 3. Here, 3 pi over 2. 10 pi over 6. And 11 pi over 6 doesn't reduce. And then back to the start, 2 pi. Okay, does that make sense? So you can write it as 10 pi over 6, but you have to always reduce your fractions, okay, with trig to get the right value. All right, so we know how to draw them, sort of. Okay, so what I'm going to do is put a random angle, and we're going to draw it without all the other ones in there. Okay, so that's what we're going to do. So we are going to draw the angle. So we'll just sort of start with one we already have. So 5 pi over 3. So what you would do is you draw your x and y axis, and here's 0, here's your start. So 5 pi over 3 is telling you that you get to eat 5 pieces of pie that's cut into thirds. So this is cut into thirds, and we get to eat 5 pieces. That's what that's saying. So these are thirds. So you take your pie and you cut it in thirds. Do we need another pie? Yeah, because that's only 3 pieces. So we need to add that second pie, cut it in thirds. This line is ignored when we have thirds. So, starting here, you count out your 5 pieces. So 1, 2, 3, 4, 5. So where would we cut so that we could eat 5 pieces? On this last line right here. This is the terminal arm. So this would be 5 pi over 3. Okay, so we start and we go around, and that would be the angle. Nope. In linear algebra, if you take linear algebra, you might be taking it now, you do degrees, but in calculus we work in radians. What I am going to do next class is show how to convert from radians to degrees and degrees to radians, but that's the only place we'll see degrees. Okay? So, let's write a second one. So let's say 13 pi over 6. So how many pieces do we cut our pie into? 6. Does this reduce? No. You always check that, but I'm not giving you ones that we need to reduce first. Okay, so it doesn't reduce. We need to cut them into 6. So 6 pieces. We need a second one. Now if we go around, how many pieces are going to be here? 12. Because one whole pie is 6 pieces. Another pie would be another 6 pieces. So what do? Go one more. Think of it as another Joe Louis piled on top of it. We have to go one more piece to get to 13, so our terminal arm would be here. 13 pi over 6. Okay? So far, so good? Now, what if the angle is negative? What happens? Negative 2 pi over 3. Right, instead of the start and going up and around, we're going to go backwards. So that's the only difference. You still cut it into 3 pieces and count out 2, but you're counting them in the opposite direction. So positive angles go in this direction, and negative angles go down from the start. But it's the same idea. So where would negative 2 pi over 3 be? So we are going to start backwards, so we need this first one. Here's our start at 0, and we want to cut our pie into thirds. We're ignoring this line. And we want 2/3. So this is 1, 2, going in the backwards direction. Our terminal arm is right here, negative 2 pi over 3. So my question is, in the positive direction, what is this angle equivalent to? So what am I saying is if we were going around in the positive direction, I want to land on that same terminal arm, what is the angle? So if this is cut into thirds, 1, 2, 3, and one more is 4. So this is the same as 4 pi over 3. In the positive direction, that terminal arm, or that cut mark, would end as if you ate 4 pieces. Is there any other equivalent angles to this line? We could actually go on the rest of the course only doing that one question. Why? I can keep circling around, and every time that cut mark lands on that line, it's the same angle, or it's equivalent angle. Okay? So what would the next one be if I went around in that circle again? How many pieces would I be adding? A whole circle around if they're cut into thirds. Right, it's thirds. So, and there's 2 pies to go a whole circle, so that would be 6 more pieces by the time I get around. So if I went one more time around, that would add 6 pieces. So that would say what? 4 pi over 3 plus 6 more pieces is how many pi over 3? 10. Don't write it as a fraction because you're actually adding 6 pi over 3 to 4 pi over 3, but think of it in pieces. If we're at 4 and we need to add 6 more pieces, we're at 10. What if we wanted to go around again? 16. Again? 22. Those will all give you the same trig value. Now what about backwards? 6 in the opposite direction. So if we had negative 2 over 3, what's 6 more? Negative 8, right? If you subtract 6 from that, again, negative 14, and so on. Those are all equivalent. They're not equal because they are a different number, but they'll give you the same value in trig, okay? All right, now do you remember the cast rule? So we're going to write it in here, and that was on your memorized sheet. Do you recognize that? So in calculus books, they don't call this the cast rule. They call it the all students take calculus rule. Why do they like that better? Because A is in the first quadrant, right? So they wanted something, cast is kind of backwards. The C is not in the right quadrant to read it, right? Because this is quadrant 1, 2, 3, 4. Right, so they say all students take calculus to make sure it's in the right spot. But what do these stand for? Someone knows. What's your guess? C is cos, sine, tan. What's the A? All. Okay, so the A stands for all. So that's all, and the S is sine, the T is tan, and the C is cos. But what on earth does that, are we trying to remember by doing this? It is telling us what quadrant each of them is positive. So let me write that down in a second. We're going to back up a bit and draw a sine wave. Now, this goes on forever in both directions. Okay, so you remember drawing these in high school, I am sure. If you took pre-calculus in high school, you did a lot of this. You had to make them bigger, smaller, change the period. They grew, they shrunk. Do you remember doing that? Who remembers doing that? Yeah. We're not going to do that, although that does exist, and you will probably have to do that in your life if you take more math, but we're not going to look at that right now. Here's the sine wave. It starts at 0. On our table of values, we had 0 at 0. That's the point 0, 0 on the graph. 0, 0 is the point on the graph. When we plug in 0, we get 0 out as the y value. So that's a point on the sine graph. It starts there. The next point on this table brings us here. So this is the point 0, 0. The next point on this table is here. This is pi over 2 is up to the value 1. So on our table, at pi over 2, these are the x values. At pi over 2, the value is 1. What's the next one? At pi, it's 0. So let's just write these on here. This is pi is 0. What would this be? negative 1, so that was 3 pi over 2 is negative 1, and back to the start, which is 2 pi is 0. And this can keep going on, but we keep getting the same values over and over and over again. And that's what these circles are for. So these circles, when we go around and around and around, we're still getting 0, 1, negative 1, 0, 1, negative 1, 0, 1, negative 1 in the same place. Because this is a wave. It goes up and then back down. And this shape, this original shape right here, is sort of our 2 Joe Louis that repeats. So here it is, the start one, the first one, starting at 0 and ending at 2 pi. And then it repeats again. The values are all the same. When we get right here, it's the same. It's 1. When we get here, it's the same as this one, 0. When we get here, and it just does it over and over again. We could keep going around and around and around and around and keep getting the same values over and over. So that's why it repeats. The other values are in here. Pi over 4 is a quarter. It's right here, and that value is root 2 over 2. And one of them is a half. They're all in here, a 6, a quarter, and a third, okay? And they repeat again over here. And they repeat again over here. These values below are the same number, but the opposite sign. And that's the cast rule. It's telling us where we're landing on this graph. All we need to look is at the angle itself in the cast rule to determine whether that half is up here positive or if it's down on one of these lower ones and is negative. So just looking at sine itself, sine goes positive because these are above the axis. Here's y is 0 right here. So these are positive, and then what? Still positive. These values are still above the axis. And then they go negative, and still negative because they're below the axis. So the cast rule says positive is the first one, all are positive. So they all up here in the first quadrant. Sine is still positive when we're leaving that value because these are y values that are still positive. They're above the axis. Then it goes negative for the next two, and that's this part and this part. They're below. And then it does the same thing again, plus, plus, minus, minus, plus, plus, minus, minus. So that's where it's coming from. You don't really need to remember the shape for that, but what the cast rule says is that all trig are positive in this first quadrant. The answers are all positive numbers. Here, sine is positive. And if sine is positive, what do you think about cos and tan? They're not. So they're negative in that quadrant. Here, tan is positive, so what about the other two? So cos and sine are negative here in this quadrant. And here, cos is positive. So that means that sine and tan are negative here. Okay, so what we'll do next class is we'll pick up here. We're going to draw the cast rule and the angles together, okay? So